Okay, now we're going to learn about two special types of sequences and series. The first type we're going to learn about are called arithmetic. So an arithmetic sequence is a sequence if there's a number d so that the next term equals the last term plus the number. So this just means you're adding the same number every time. And the number could be negative, so it could look like you're subtracting. So for example, if we had something like 1, 3, 5, 7, where we're just adding 2. So there, D is called the common difference. So here, D would be 2. Or we could have something, let's say we have 7, 2, negative 3, negative 8. Here, we're subtracting 5 each time. We'd say D is negative 5. Okay, so first it says, write the first 5 terms of the following arithmetic sequences. So A1 is 3 here, and then our D is 7. So we're just going to add 7 every term. So A2 would be 10, A3 would be 17, A4 would be 24, and A5 would be 31. Okay, here it says A1 is 6, and D is negative 2, so A2 would be 4, A3 would be 2, A4 would be 0, and A5 would be negative 2. Okay. Now, to be able to write the formula, and this is what we did kind of on that last one, we were trying to write something in some summation notation. The nth term of an arithmetic sequence with the first term A1 and common difference D, AN is A1 plus N minus 1 times D. Okay, so you may find that formula helpful at some point. And then we also have a formula to find the sum of the first n terms. So the sum of the first n terms of an arithmetic sequence, you get this little formula. The sum is equal to n, so how many terms you're taking. So how many terms you're adding. So A1 is the first term, and AN would be the last term. Okay, so here if we want to add from n equals 1 to 12, and notice this has to be the first n term, so this only works if you're starting with 1. So here our n is 12, so our sum, we're going to have 12. A1, if we plug 1 in here, we'd have 6 times 1, which is 6, plus 4 is 10. Then we would plug in 12, since that's our last term, so 6 times 12 plus 4, which gives us 76 all over 2. So this will be 12 times 86 over 2. Which gives us 516, which is obviously much quicker than adding 1 in there, than putting 2 in there, than putting 3 in there, and adding them all up. Okay, next we want the sum from 1 to 20 of 2n minus 4. So our n is 20. We want to just get them A1, we would plug in 1 and we'd have 2 minus 4, which would be negative 2. And A20, we'd have 2 times 20 minus 4, which would be 36. So our sum here, we'd have 20 times negative 2 plus 36 over 2. And our sum here would be 340.